Welcome to this lecture. In the last few lectures, we looked at the UML. The UML is a modeling language and different types of views of a problem can be created, but we looked at only 3 or 4 diagrams. We looked at the use case diagram, class diagram, object diagram, sequence diagram, collaboration diagram and the state machine diagram. There are of course other diagrams, but we did not discuss those, and those diagrams are not really needed in very simple problems. For specific category of problems, we need activity diagrams and so on. Now, we will look at a design process. The design process will tell us, will give us information about how to go about. When a problem is given to us, how do we go about, what are the steps through which we will carry out our design, and we will use the UML to document the results of our process. So, let us look at this design process, and if we understand this well, for any given problem we can use this process or the number of steps that are there here and come up with a reasonably good design, and the UML is of course used for documentation and helping carry out the steps. Let us look at the design process. So, here the design process that we look at is to a large extent based on the Lerman's approach, but of course, if we look at any other design process, there are only minor variations, but it is largely the same thing. And in our approach, we also use features from other methodologies. Here we have the requirement specification available to us, and based on the requirement specification document, we develop an initial model which we called as the analysis model, and then we refine this to obtain the design model. And the design model, as we proceed in the design step, good amount of code is also automatically generated, and then during the implementation we need to fill up some of the missing code. If we diagrammatically show our approach, at the very overall overview of the approach is that we have an analysis stage, call it as an object oriented analysis, and here based on the requirement specification we analyze the requirements and develop an analysis model, and this analysis model results in a domain model and use case model. So, the outcome of the analysis here are 2 diagrams. One is the use case model and the other is the domain model, and then we use these 2 diagrams to carry out the design process and also the programming object oriented design, and some code is also generated during the design process. Here we construct the solution. In the analysis problem, we analyze the problem and model the problem. This is not really design, because we do not generate the code from here directly, this is the analysis model, but the design model takes into consideration the specific implementation that we need and the design that needs to be performed for that. So, it is a refinement of the analysis model, and here some code is also generated, and based on the design we can complete the program. Let us be clear, how is the object oriented analysis different from object oriented design? We have already discussed in some form in the previous slide discussion, but now let us be clear, how is object oriented analysis different from object oriented design? In the analysis, we only elaborate the requirements, we model the requirements, and we elaborate, we create detailed models of the requirement, and the analysis model can be implemented for in any situation. So, it is a very general purpose one, and it is not specific to any implementation. On the other hand, in the design step, we take the analysis model and look at our constraints that we have for the solution, and then we create the design model. As we proceed, this point will become clear that initially we develop the analysis model. This is a very general purpose model of the problem, and then depending on the specific constraints we have, we create the design model by refining the analysis model. In our design process, we generate the use case diagram and the domain model during the analysis stage. These are general purpose diagram, and for specific implementation we do the object oriented design based on these two diagrams. Here we start with, we have the SRS document available to us, and we will see, given the SRS document, how do we develop the use case diagram. And for developing the use case diagram, the GUI prototype is helpful to come up with a good use case diagram, and we use the SRS document and the use case diagram to develop the domain model. We will see what exactly is the domain model, and then based on the use case and domain model, we develop interaction diagram, the sequence diagram, and its dual, that is the collaboration diagram, which can be automatically obtained from the sequence diagram. We develop that, the interaction diagram, and based on the interaction diagram that we develop and the domain model, we develop the class diagram. As you might remember that we are discussing, the domain model has only the class names, and the interaction diagram, as we develop, it adds the methods to the classes, and then we add the attributes and so on based on the methods, and we obtain the class diagram, and based on the class diagram we can write the code. But then we have a glossary that is prepared throughout the process, design process. Here, as we elaborate the requirements, we might come up with new terms, concepts, etc., which we add to the glossary, and during the interaction diagram, class diagram, we come up with several new terms, and we write the meaning of those terms in the glossary. So, the glossary development occurs throughout the design process. We can also model our design process in this way, that initially we develop the use case model, which is the functional requirement. We take the SRS document and we create the use case model out of that, and from that we develop the domain model, which is the conceptual class diagram, and then based on the use case model and the domain model, we create the interaction diagrams, and that will lead us to the class diagram, and meanwhile we keep on defining the glossary. So, the outcome of the analysis model is the domain model and the use case model. We have seen while we were discussing about the use case diagrams, how to develop the use case model. Therefore, we will not be discussing development of use case model here, already discussed that in the context of UML. We will discuss about the domain model. The domain model is the initial fast cut class diagram. We analyze the requirements document and we look at the use case model and develop the initial class diagram. We will see that it is not very complicated. If we have the use case diagram developed well and we have the requirements document available to us, domain modeling is not very complex. While developing the domain model, we look for three types of objects. One is called as the boundary objects. These are the user interface objects. The entity objects and the controller objects. So, these are three categories of objects that we look for while doing the domain model, and in the domain model we represent these three types of classes. We will discuss what exactly are those, the boundary, entity and the controller object. But in every case tool we also use similar approaches to come up with the design, and we look for three types of classes, that is boundary, control and the entity. And since these classes are used frequently, we have stereotypes for that. Instead of writing boundary, control and entity, we have these symbols in most of the case tools. The boundary classes are the user interface. For example, a cashier interface we represent using this symbol. These are not the UML symbol, but then most case tools they use these symbols so that the design activity becomes simpler. The control, for example, a withdrawal manager is a control type of class and we represent using this symbol. And the entity classes, for example, an account class is represented by this type of symbol. So, if you are using a case tool and you come up with this kind of notation, or in any other book or paper, you can relate that in any specific problem during the analysis step we develop the domain model, and in the domain model we look for three types of classes, the boundary, controller and the entity, and these three we can have represent them using these symbols. Now, first look at the boundary objects. These are the user interface objects and the actors they interact using the boundary objects, and the different types of boundary objects are screens, menus, forms, dialog boxes, check boxes and so on. So, these are basic GUI objects, and here the main function of the boundary object is to collect the user input and maybe to validate, and also to output the display to the user and maybe format the output. So, the boundary objects are concerned with input and output, input data from the user using specific type of forms, screens, menus etc. These are the GUI objects, and the boundary objects are also used for displaying the result. but remember that these do not do any processing, they are just these type of objects, they are just used for collect information from the user and to display the information. The second type of classes that we look for are the entity objects. The entity objects, they store information. For example, in a library we have a large number of books, and for each book as we create, we store the name of the book, the author, the ISBN number, the cost, etc. So, this information is stored for a long time. It is not that each time the book is issued, etc., these are lost. Once the book is created, it remains until after several years or something gets you discard the book. So, the entity objects, they store data, just like we saw that the book stores some data like author name, book name, ISBN number, etc. Similarly, book register is also a entity object. It contains what are the books available and which are issued out to whom. Similarly, we might have members, member register, all these are entity objects. And we call these objects as dumb servers because they do only very simple processing like store some data, look up some data, or maybe sort, etc. And the entity objects are normally identified by reading the problem description and finding the nouns there. The nouns, as you will see, they mostly indicate the entity objects. The third category of objects are the controller objects, and the controller objects are in overall charge of executing a use case. As soon as a use case is executed, the user uses the boundary to enter some request, and then that gets reported to the controller object. The boundary, the initial request is reported to the controller object, and the controller object, it interfaces with the boundary object, gets the request from the user, and once the request from the user comes, the controller object stores a logic inside it, knows that how to realize the required behavior, that is which objects need to participate in this use case execution. It sends them specific messages, collects the information and sends to other set of objects, and so on. So, we can say that the controller objects are the one which have the business logic required for use case execution, because at the start of a use case, the controller object is reported about the user trying to execute, let us say want to issue a book. Then the controller object knows the business logic. It would check, for example, whether the book is reserved before the book is issued. It will check whether the member can actually issue it, whether he has exceeded his quota, and so on, and finally it will issue it and store the information in a book register, and finally print the issue slip. So, the controller object is an important class object. For every use case, the controller object, corresponding controller object gets the control, and it determines what are the steps through which the use case can be executed, which objects need to interact, and it requests those objects to do their specific part of the execution. We can say that the controller objects coordinate sequence, transact and control other objects. So, these are the ones which are the brain behind the application. They coordinate the boundary objects and the entity objects and get the work done. The work that is required as part of a use case, these are done by the controller object. And the term possibly comes from the Smalltalk model view controller mechanism, and from there possibly the name is come as the controller classes. If we see how the use case execution proceeds, the boundary gets the request and it passes on the request to the controller. The controller knows the business logic, that is which entity classes to request to get the work done, and it sends the request to entity 1, and the entity 1 may collaborate with entity 2, entity 3 and return to the controller. The controller might request some other entities and so on. So, depending on the complexity of the use case, the business logic that is stored in the controller can be rather trivial or may be very complex, and it takes the control and coordinates the actions of other classes and finally returns the result to the user. Now, let us see that how to identify these three types of classes. Given a problem description, we are trying to solve a problem. How do we go about to identify the three classes of objects? The simplest are the boundary objects. For this, we need to just examine the use case diagram, and for every actor and use case, we draw one boundary object that indicates the overall interface required between the use case and the actor. In this simplest use case diagram, we have only one actor and one use case, and therefore, we have only one boundary object. But for this example, we have 3 use cases and 4 users, and we need a boundary here, So, we need 4 boundary objects. So, we can say that the number of boundary objects, we look at how many use case actor pair exist. Use case actor here 2, use case actor pair 1, so total 4. So, identifying the boundary objects is rather straightforward if we have the use case diagram available to us. We just look at every boundary here between use case actor and have one boundary object for that. Now, let us see the controller objects. This is the second class of objects. Identifying the controller object is also straightforward. We know that each controller class realizes behavior of one use case, and therefore, by looking at the use case diagram, we just count the number of use cases and we need that many controller classes, and each controller class has the business logic to realize the behavior for that use case. For this simple diagram, we have only one controller required because there is just one use case. For this diagram, we need 3 controller classes: the register customer controller, register sales controller and select winners controller. To start with, we just have one controller class for each of the use cases. for any problem, but as we proceed with the design, we might see that for some use cases the controller class becomes extremely large, very sophisticated business logic, and then we need to split those controller classes to simpler multiple controller classes. Now, that brings us to the third category of classes, that is the entity objects. Actually, these are the hardest. The boundary classes and controller classes are easily identified. Just by inspecting the use case diagram, we can very quickly identify the boundary classes and controller classes. But entity classes, these require more experience and thought, and we need practice in identifying the entity classes, but some guidelines exist. Let us look at how to go about, because this is the most crucial task. The other two, identifying boundary and controller classes, are rather straightforward. Let us see how to go about identifying the entity objects. Typically, the entity objects are identified as noun analysis, because the entity objects occur in the noun. Initially, when we are new to the object oriented design, we need to underline the nouns and then see which nouns satisfy, or they can be considered as the entity classes. But as we become more experienced, we do not have to really identify each of the noun. Just by reading the problem description, mentally we can determine which are the entity classes. But to start with, we underline the nouns in the problem description, and then all nouns are not entity objects. We exclude several types of noun. For example, if we have nouns like accountant, librarian, etc., which are the users, we exclude them. But of course, sometimes we need to have some of the users also as classes. For example, a library member is a class, and that but many of these are not users, are not classes. Many of the users are not classes. The passive verbs also appear like noun, but they are not really entity objects. And also we look at the nouns, first eliminate the users and passive verbs, and then we look at the nouns and try to associate some data and methods. If we see that we cannot really have meaningful set of data associated with the noun and meaningful set of methods, then also we eliminate that. Even though most of the users we eliminate, but sometimes we need to have some users as classes. As I was saying, that library members are classes because we need to store information, that who are the members, what books they have borrowed, and so on, and these are called as surrogate user classes. We are almost at the end of this lecture. We will stop here, and we will see how to identify the entity classes for specific problems, and then we will take up few problems, and then we will walk through the design process and see that how do we develop the domain model, and then the interaction diagram, and finally the class model. That we will do in the next lecture. We will stop now. Thank you.